Hello, whoever is watching the video. I did my A levels in 2023, and in year 13, I found these tricks when doing integration. Let's get started with it. So, when you integrate 1 over cos squared theta or 1 over sin squared theta, we normally know that we cannot integrate them. So, we have to convert cos squared theta and sin squared theta into half plus or minus half cos 2 theta, but not always that works. So we can make 1 over cos squared theta into sec squared theta because that is basically that, and 1 over sin squared theta to cosec squared theta, and then integrate because we know that sec squared theta is equal to tan theta, because we can find it in the formula book, which is this one. And then we can integrate cosec squared theta into minus cot theta, because if we see here in the differentiation one, we can see that we differentiate cot x into minus cosec square x. So if we do the opposite, it will be cosec square, and the minus will go into this part and became minus cot. So cosec square will integrate to minus cot theta or cot x. So in number 2, if you have to integrate tan squared theta, then use the Pythagorean identity. And by the Pythagorean identity, I meant these formulas. You can find them in year 13 pure book, so pure book year 2, which is we learned this one in year 12. Sine square plus cos square is equal to 1. And in year 12 there was other one, like tan is equal to sine over cos. And in year 13 we learned 1 plus tan square is equal to sec square, or 1 plus cot square is equal to cosec square. And here we can rearrange this formula, so 1 plus tan square is equal to sec square into this. So tan square would be sec square theta minus 1. Rearranging this to make it equivalent of tan square. Then we can do is integrating tan square theta would be integrating sec square theta minus 1, which would be tan x minus x plus c, because sec square integrates to tan x. And you can do this for also for integrating cot square theta, because we can rearrange the formula from 1 plus cot square is equal to cosec square to make it equivalent of cosec square minus 1. So in number 3, I took this PowerPoint from Dr. Frost, and it says about when integrating sec x, sec x does not change the power like in the answer. Here is an example, um, and they use the chain rule here. Yeah, they use the chain rule. So look, we have sec to the power of 4 here. Then in the answer also we have sec to the power of 4. So when you do integration, if you have sec x and you have a power and you get the same power in the answer, there is nothing to worry about. Let's go in number 5. I mean number 4. So it says, if it is integration by parts and it is a show that question and you don't get the answer, try to take u is equal to the other one and dv over dx is equal to other one. Here I meant for integration, for example, we have x cos x something, like we have to integrate this. So normally for integration by parts, we take u is equal to x and dv over dx is equal to cos x. Then we find this and we find the derivative of u. So if we do this, sometimes the answer, like, you don't get the answer, because sometimes in show that question, it says to find the answer and you don't get it. That then you can do is take u is equal to cos x and dv over dx equal x. Then you can find x, sorry, v and du over dx. Yeah, that's it. My English is so bad, so bear with me, and maybe this will be useful. Bye bye.